vamos a tener una presentación en parte sobre Python, pero es más genérico, de patrones de diseño en ingeniería de software, por parte de Luciano Ramalho. Luciano Ramalho es un desarrollador brasileño al cual me une una coincidencia bastante estrafalaria, además de nuestro interés por la programación y por Python en concreto. Él trabajó durante 2 años en un centro de información médica de Naciones Unidas, del cual mi padre fue director hace ya mucho tiempo. Entonces fue una grata sorpresa cuando compré un libro de Luciano Ramalho y vi en su biografía esta coincidencia. El libro en cuestión se llama Fluent Python y creo que es uno de estos libros que todo desarrollador de Python debería leer. Es probablemente uno de los mejores libros genéricos de Python avanzado. Si quieres de verdad entender y escribir código fluente en Python, es decir, sin tener ningún acento extranjero, este es un libro que hay que leer sin duda. Estamos ahora a la espera, parece que aquí está. Luciano parece que está teniendo algún problema para conectarse, pero está. Luciano, tudo bom?
Tudo, e com você?
Tudo ótimo, tudo ótimo. Luciano, eu estava te apresentando um pouco, mas eu acho que melhor você mesmo fazer. E acabo de perceber que eu estou falando em português. E provavelmente ninguém... Okay, so we'll switch to English. I was speaking in Portuguese because I lived in Brazil for a very long time, and Luciano is Brazilian, and I didn't even notice it. So, Luciano, why don't you introduce yourself?
All right. Well, first of all, thank you very much for inviting me. I'm really sorry that my Spanish is not up for giving a presentation, but in fact, this presentation I've already done it at Pi Caribbean in Santo Domingo, in the República Dominicana, but I did it in English. So sorry about that. So about me, I am 54 years old. I learned to program in the late 70s. I'm going to talk a little bit about that in the talk. And now I work for ThoughtWorks. What you're seeing around me is the ThoughtWorks office in São Paulo. ThoughtWorks is a software consultancy that has offices in many countries, including Spain. They have an office in Madrid and another one in Barcelona. And I'm really proud to be working for ThoughtWorks because I've been a big fan of Martin Fowler, for instance, for many years, and he is my colleague. In fact, I sometimes exchange emails with him. And yeah, so that's me. But my biggest claim to fame is the fact that I wrote a book called Fluent Python that has been translated to several languages. I don't think there's a Spanish translation, but I'm not sure. Yeah, because already it takes several months to tell me about translations, but it has been translated to several languages, and the book was well received, has very good ratings, and it's selling well for a technical book. Anyway, so that's a little bit about me.
Excellent. And I was just saying that it's a book. It's a book that I think that every Python developer should definitely read it. Anyway, Luciano, if you want, you can share the screen and we can get started.
Yes, let's try that. So what I'm going to do, I'm going to share. I think I'm going to share a preview. No, let's try with Keynote. See if that works.
Okay.
Let me see. Oh, we use Zoom at ThoughtWorks. So, okay, so let's try this. And then if I hit play, what happens? I probably are seeing the wrong thing.
Yeah, we can see it. Yeah, it seems to be working fine. So,
do you see just one slide or two slides? What are you seeing?
Excuse me?
What is showing to you? One slide or
The
two
slides.
slides?
We're seeing your slides right now.
Just one slide or two
Two.
slides?
Two
Okay,
slides.
so that's inverted. I didn't want to do that. Let me try and see how can I do the other way. So maybe I should share the other screen. Yeah, that's what I'm gonna do. So again, how do I stop the screen share? Okay, okay, I'm gonna share this screen, and then now are you seeing a slide full screen? Just one slide?
Yes, a single slide
yeah,
this time.
except that it's the wrong presentation. Sorry.
Okay.
Yeah,
that one's in Portuguese. There you go.
Yes, exactly. So this is the one. Beyond paradigms, right?
Yep.
All right.
Everything perfect.
So let's get started. Yeah. So I have my sort of a business card to introduce myself, and this is the book. We already talked about that. So let's jump right in and talk about paradigms, right? So like I said, when I learned to program, those are the first two devices that I learned to program were programmable calculators, because in the late 70s in Brazil, we had a military dictatorship that had a crazy idea that we should have a national computer industry. So it was basically forbidden to import computers, but it was not forbidden to import calculators. A lot of people learned to program. A lot of people of my age that learned to program at the time learned with calculators. And programming calculators, look, this is a program from the HP25 calculator. This is the best example of an imperative paradigm, right? Because you're actually telling the machine, take this value from this memory position and put in this register, and then do this operation, add with the other register, put the result back in memory, and so on. You are really giving very detailed instructions. There's a book that I like. I'm passionate about programming language design. So that's in my book I write a lot about the design of Python and also the design of other languages. Sometimes I compare Python with other languages. And this is an interesting book about programming language implementation in general that I like. And this is one example that is in the first chapter of the book, the Gcd algorithm, the greatest common divisor algorithm in assembly. Looks very much like the calculator languages that I learned. And then the author also shows the same algorithm implemented in C, or Camel, and Prolog to discuss different paradigms. And this is, for instance, the same algorithm implemented in Python. And I wanted, so on the left, the imperative style, on the right, the functional style. I cannot see you, so sometimes when I give this presentation, I ask people who prefers the left one, who prefers the right one. I think the right one is more elegant. How can we tell that it's
I prefer the functional one, the recursive one, but
yeah.
I'm not sure if you get if it's safe in Python. Is Python 3 tail recursive?
Not. It's not. So this is the next slide. Yeah, this is beautiful. The left one is beautiful, but it doesn't work well in Python. But let's just take a look at the code to see what makes it a functional style code. First, there's no assignment anywhere, right? On the left side, there are assignments of values to variables. And on the right side, there is no assignment. And there is no loop either. It's just, the looping is done via recursion. And like Fernando just pointed out, Python doesn't have tail call optimization, which is a feature that pretty much any real functional language must have to support this style of programming. Since Python doesn't have it, this example works for small numbers and it's really inefficient even for small numbers. But anyway, so this is a first insight that although you can program in different styles in Python, Python supports different styles of programming. Sometimes one style works better than another in Python because of features that the language has or doesn't have, right? So that same book that I
Luciano,
mentioned
Luciano,
before.
sorry to
Yes.
interrupt you, but just a short question. Are there any plans to implement tail call optimization in Python 3?
No,
No?
I don't think so because there's actually an old blog post. Here's the thing, Fernando, please interrupt me. This is great, okay? And if people over there have questions, if you can relay them to me, I will be very happy to answer because I think the presentation works much better if we are interacting. So about your question, I read a blog post by Guido. It's pretty old, probably more than 10 years old or 15 years old, something like that. But Guido van Rossum actually wrote a blog post explaining why Python doesn't have tail call optimization. And the reason is because they couldn't figure out a way of doing it that wouldn't make uh, tracebacks harder to understand. So because they thought that it's a feature that only a minority of the Python programmers would actually use. It wouldn't make sense to make tracebacks harder to read for everybody if only a small percentage of the community would benefit from it. So that's the position that Guido stated many years ago. Uh, yeah. So anyway, in that book by Michael Scott that I mentioned before, he has a box about where he talks about classification of programming languages, and he has this classification between, has declarative and imperative, and within those categories, other categories. But I think this classification is pretty bizarre because I don't really see any sense in this scripting category. It's hard for me to find a technical reason why Python would not be on the same line as Smalltalk. But I have a theory. Maybe it's a conspiracy theory, but it's my theory. My theory is that Python is not on the object-oriented line because of academic prejudice against scripting languages. So Smalltalk was the languages on the object-oriented line were all developed by people who had PhDs, and the languages on the last line, the scripting languages, were developed by people who did not have PhDs. So there's not a lot of academic work that preceded those languages, and I think that's the main reason why they were categorized in this way. That's my theory. Anyway, regardless of the reason why Python is not on the same row, I think it's strange and I can't find an explanation. I think this is wrong about this classification. There's a book in Portuguese by professors from the University of São Paulo where they present this other classification. There's a mistake in the diagram, but the book explains correctly, just the diagram is wrong, but it has this other classification, okay? And then there's this site that I discovered by a university in France called the Language List. Supposedly has information about 2,500 computer languages, but the languages themselves are lost. However, so the actual languages are missing, but there is this page called language categories, which is a really long page with many categories, right? So you can really go crazy categorizing languages. And this whole discussion about ways of categorizing languages and the odd classifications that sometimes we find reminds me of this work by my favorite writer, Jorge Luis Borges. And he uh, presents in one of his short stories, the short story called El Idioma Analítico de John Wilkins, this classification of animals, right? 14 categories. So, pertenecientes ao imperador, embalsamados, amestrados, lechones, serenas. Anyway, I won't read everything, but it's, saying I like the K category, which is dibujados con un pincel finísimo de pelo de camello, etc. L, not the last one, interesting, que acabam de romper jarrón y que de lejos parecen moscas. Anyway, classifications usually don't look so strange, but sometimes I'm reminded of Porges when I study classifications. So there's an example. There's a great article that I'm going to quote shortly that talks about categorization and ontologies. And in that article, the author mentions this example. So this is a classification that we can all agree is based on hard facts, right? The position of the atoms is determined, of the elements is determined by the number of protons in the nuclei, and the rows are according to the number of electrons, right, on the outer shell. But even this classification is problematic because of this column here. Because first of all, because of the name, noble gases. Why are they called noble? One explanation that I found was that because, like people from the nobility, they don't mix up, right? Those elements don't appear in nature in molecules because they have their outer electron shell complete, so they don't interact with others. And also the fact that they're named gases in the classification is also wrong. Well, the fact that they're noble is not wrong, it's just weird, something from 19th century culture. But the fact that they're called gases is just plain wrong, because at the time when the classification was done, it was believed that those elements would always appear as gases, but later it was discovered that no, if you lower the temperature enough, you make them liquids and even solids. So anyway, classifications are prone to imperfections. Even this one, which is probably the best one that that humans ever invented, is also not perfect. And so this is the title of the article. Ontology is Overrated, and it's by Clay Shirky, who is a professor at the University in New York. I forgot if it's NYU or Columbia. But anyway, anyone who works with, for anybody who works with information, I strongly recommend reading this article. Because for me, it was really an eye-opener, because he explains that people put too much faith in classification. Sometimes you think, oh, okay, that classification is kind of wrong, but I can fix it. No classification will ever be perfect, because people who are dealing with whatever you're classifying will have different needs, different ways of organizing that makes more sense to them. So this whole idea of having a classification of programming paradigms is flawed. It's useful as a first approach, maybe for the first lesson in a course about programming languages, but it's not something that is really something that we should take so seriously. And so what's a better approach? And this is the key idea of this talk. So the better approach I discovered when I studied this book. Well, actually, this is a paper where the author, Sridhar Krishnamurti, explains the book. This is Sridhar Krishnamurti is a professor of computer science at Brown University, and he is also part of the PLT group there, the Programming Language Theory group. And they are the authors of DR Scheme and DR Racket. You know about those?
Yes, I know about him because of his involvement in the scheme language.
Yes.
And
Exactly.
I read he has also a book called How to Design Programs. It's
Mhm.
a book
Oh
to
yeah.
teach
Yes.
programming at
Yes.
undergraduate level. But I wasn't aware of this one. I hadn't seen it.
Yeah. Well, so this is a paper, and I really love the first sentence of the abstract here. Programming language paradigms are a moribund and tedious legacy of a bygone age. This is a very strong opinion, right? And I'm glad that I can uh, share this opinion. That's his, not mine. It's not me that I'm saying, it's this professor. Anyway, and he says, furthermore, modern language designers pay them no respect. In the body of this article, one of the languages that he mentions that pay no respect to paradigms is Python, right? Uh, and Go is another language that is becoming very popular that is really hard to, doesn't really follow any particular paradigm to the letter, because Go has objects, but it doesn't have inheritance. It has interfaces, but in a way that's different from every other statically typed language that I know. So anyway, and so he proposes that this method of teaching languages based on paradigms should be abandoned, and he is going to describe a textbook that explores these matters. This is the paper, uh, and the actual book is this. So the book is called Plai, it's known as Plai, Plai, Programming Language Application and Interpretation, and it's really interesting. It uses Racter, which is the scheme dialect that they are continuing to develop at Brown in his group. And what's the idea of this book? The idea is it has a really modern, very interesting approach to teaching programming language. And the first thing is he believes that it's important that people understand how a programming language is actually implemented. So, because the implementation, the actual code, is the way that we formalize concepts in computer science, or one way that we formalize concepts. At least is one way that that undergraduate students can understand, and anybody who can program can understand a programming language implementation, and then really understand, at a very deep and at a very uh, formal, in a very formal way, the semantics of the language. But the second idea that he has is that instead of doing that by implementing a compiler, which is a common approach in many computer science university programs, he thinks that it's much better to implement interpreters for this purpose as a first approach to understanding more formally how programming languages work. And why is that? Because it's much easier to implement an interpreter than implement a compiler. So in one semester, you can actually implement several interpreters instead of just one single compiler for a very simple language. And by implementing different interpreters, people can get in touch with different language features that are important to understand. Like, for instance, tail recursion. How do you do that? Uh, uh, anyway, so this is the idea of his book, is to implement different interpreters showing fundamental language constructs. And there's actually a very old book that I found that follows the same approach. Uh, One day I would like to actually rewrite the examples in this book, from this book, which are in Pascal, using Python, but I never found. I actually did that with the first two chapters, but the book is much longer and I didn't finish this project. Anyway, it's a very interesting approach, I think. So let's talk a little bit about another issue that will converge with this idea of the language features that we just mentioned. So design patterns, everybody knows the book. And the book actually has this quote, which is really interesting, right? the authors say that our patterns assume small talk or C++ level language features, right? And the next sentence is really interesting. If we assumed procedural languages, we might have included design patterns called inheritance, encapsulation, and polymorphism, right? So I don't know how many of you remember of the Palm digital assistants. That was something before we had smartphones. Some people had a cell phone and this PDA, like a Palm, which was another small computer that had your contacts and reminders or things like that. Anyway, the reason I'm mentioning Palm is because to create a Palm application, you would write C code, not C++, C, but it was object-oriented C. So how do you do object-oriented C? By being very disciplined and implementing by hand the patterns. So for instance, so methods, they actually looked a little bit like Python methods, because methods in object-oriented C always have a first argument that is the receiver, like our self in Python, right? And actually, if you have to do a lot of things by hand, to implement inheritance via pointers to the superclass and so on, but you can actually do everything in C. It just takes a lot of work and a lot of discipline. But this is interesting because this makes clear already in the book, and this is only on page 4. So in the very beginning of the book, they talk about this idea of the relationship between design patterns and features that may or may not exist in a language, right? And a couple of years or 1 year after the original design patterns book was released, Peter Norvig, who is a professor of computer science at Stanford University and also a director of Google, made this presentation. I've never seen the text, a transcript or the audio of this presentation. I only found the slides. But it's really interesting because of this observation that he's thinking about dynamic languages like Lisp or Dylan are the examples that he's talking about, but Python, Ruby, JavaScript are also dynamic languages in that sense. And what he says is that 16 of the 23 patterns in the original book have become much simpler in Lisp or Dylan, at least for some uses of each pattern. So, and in the next slide, he actually gives this list. And so if you look at this list, this is a list of 6 fundamental features: first-class types, first-class functions, macros, method combination, multi-methods, and modules. Those are features that exist in Lisp or Dylan. And what he's saying here is that, for instance, if your language has first-class functions, like Python has, like Java has since Java 8, you have to rethink those patterns: command, strategy, template, method, and visitor, because they become much simpler. For instance, the third item is he's talking about macros, and he's talking about interpreter and iterator. So Python doesn't have macros, but Python has incorporated the iterator pattern in the language by incorporating new keywords, like yields, right? And so, given that we have yield in Python, we don't need to implement iterators like described in the book, in the design patterns book, because we can just do a function with yield, and then we have a generator function or a generator method. And that's much simpler than implementing an iterator in Java, for example. Anyway, so this was when I found this this slide deck. It really opened my mind to the fact that we shouldn't actually become slaves of the design patterns as proposed, because those were proposed thinking mostly of C++. Most of the examples in the design patterns book are implemented in C++. A few of them are implemented in Smalltalk. But if you're using languages that have other features, this is what you should think about. So let's talk a little bit about features, right? So features have to do with core features, not mere syntax. For instance, anonymous functions is not a core feature. Closure is a core feature, because anonymous functions is just a syntactic matter, right? Oh, okay, so the language allows you to define a function without giving it a name. Or the language allows you to define a function in the context of an expression. Like Python does that with the lambda, though the lambda is very limited. But this is not really important. This is a syntactic matter. An important matter is closures. If the language has closures, this opens up some possibilities, right? So I'm gonna build a table here, and I don't want to spend too much time talking about each of the features because I also have a lot of languages here. But anyway, I want to talk about those two because I already mentioned them before in the Norvig slides. So functions as objects is the idea of first-class functions is the idea that functions are objects in the language, right? So we have that that exists in Common Lisp and other languages like Python. And classes as objects is also another idea. So let me expand this table here and talk about some other more popular languages than Lisp. So if you just look around this table, you see that Python is actually very well, at least in terms of the checkboxes. Python has first-class functions, it has first-class types, and it has iterators. And let me see, somebody's pinging me on Hangout, and I don't know if it's you or it's somebody else. Are you pinging me on Hangout, Fernando?
Excuse me?
Are you trying to talk to me via Hangout, via a chat? No.
Sorry, I didn't get it. Can you say again?
Yeah, so are you trying to talk to me via chat because I'm getting
No,
ping?
no, it's not.
Oh, okay,
It's not
all
us.
right, thank you. So it's some colleague here talking, so I'm going to ignore them for a while. All right, so what I'm saying here is that so Python has first-class functions, it has first-class types, it has iterators, and then there's other interesting features that this table talks about, like what kind of variables exist in the language. Python only has references. In contrast, I don't know how many of you are interested in Go. I'm studying Go. Go is the most complicated of these 5 languages in this regard. Although it's in general a very simple language, this is one aspect of Go that's complicated because in Go you have variables that hold values, like in C, but the value can also be a pointer, like in C. But you also have variables that behave like references, like in Java or Python. So it's a little bit confusing. But anyway, so these are some examples of fundamental language features that you should pay attention when you're studying a new language, because the presence or absence of these features will guide you whether a certain implementation makes sense or not. So just to exemplify, because all of this has been very abstract, I'm going to show some code. And this is an example from my book, but I expanded it here. There's more variations on the same theme. But the idea is, how do you implement the strategy pattern in Python? So the strategy pattern in the original design patterns book is about choosing an algorithm at runtime. You want to be able to change some business logic dynamically while the program is running. So the example that I chose here is different from the example in the design patterns book. Imagine you have an e-commerce site, and I'm going to add some labels here. So those yellow labels are the terms that they use in the book, the generic terms that they use in the book to describe the different components of the pattern. So you have a context, and the context in our example here is an order. Like, for instance, an order, you're buying something in an online store, and you have an order, right? The order class has two methods: total, which just gives the total amount, and do is a method that will that computes how much the the customer must pay, which may be less than the total because of some discount, right? So total is just the total value of every of the items that are in the order, and the due is the amount to be charged to the customer, right? And so, in order to, to be able to have different discount algorithms applied, you implement the strategy pattern. So it's what the arrow over there means between order and promotion is that each order is created with a promotion, and the promotion is an abstract class, right? That's the italics in UML mean abstract. So promotion is an abstract class that defines this interface where a promotion class should have a discount method, right? So that's the strategy. And then below you have concrete strategies, which are subclasses of promotion that have concrete implementations of the discount method, right? So in Python, you could do a doc test like this to demonstrate the use of the API. So you have customers at the top, and then in the middle, I create a shopping cart with some fruits. So the cart is basically a list of line items, and each line item is an item, like a banana, with a quantity, like 4, and a price, like 0.5, I don't know, 0.5 euro. Uh, uh, anyway, and then you have the fidelity promo that's used below, and this shows how the strategy is actually implemented or used from the perspective of an API. So when you create an order, you pass to the order constructor 3 items: the customer, the shopping cart, and the promotion that's going to be used. So in the first example, Joe doesn't have fidelity points, so he doesn't have a discount. So the total and the due amounts are the same. But in the second example, the customer called Anne, she has fidelity points, so her total is 42, but she only needs to pay 39.9. Okay, so that's the idea, and you can already see one little problem of this pattern in practice is because although it provides the flexibility that we want, it's expensive in terms of runtime because you need to instantiate a promotion for each order, right? Because each instance of order has to have an instance of the strategy so that it can do the amounts due computation. So if you have 1,000,000 orders that you're computing, you will have 1,000,000 instances of the promotions, even if you only have 3, 4, 5 active promotions. If you only have 3 or 5, 3, 4 or 5 promotion classes, concrete strategies, you are going to have millions of instances of those classes. And this problem is actually addressed in the book. And then they suggest to solve this problem that you use another pattern called flyweight. So you use the flyweight to avoid instantiating lots of different objects. So does this example make sense so far to you guys?
Yeah, so far, I'm good, at least me.
All right, yeah. So there's other 2 tests that show different promotions, the bulk item promo and the large order promo. Anyway, so this is just let's say the API, right? Now let's take a look at the implementations, and we're going to look at 4 different ways of implementing this design pattern, the strategy pattern in Python. So the classic implementation is this one. This pretty much follows the recipe in the book. And you see there's the last argument of the dunder init method. I use dunder to describe those methods that have under, init, under. So the dunder init has a promotion. It's an optional argument. And then you see in the third method, the do method, if the promotion is none, then the discount is 0. Otherwise, we invoke the discount method in the promotion to obtain the value of the discount, and then we subtract that uh, from the total, right? So that's where the strategy is used. So this is the context of the strategy pattern. This is the actual strategy. It's an you would do this in Python as an abstract base class, which is our way of declaring formal interfaces in Python, right? Since we don't have the interface keyword, we use the same mechanism that the C++ programmers have been using for decades, which is to specify to use abstract classes to specify interfaces, right? So this class promotion is an abstract class that has an abstract method called discounts. And below, you see a concrete strategy, right? The fidelity promo, which implements the discount method. And so it makes the computation over there. And there's other examples, more complicated examples, the book item and the large order promotion.
Luciano, it all makes
Yes.
sense, but it has this Java feeling to me. It looks more like Java code than Python.
Yes, totally. And in fact, I'm glad that you mentioned Java in this context, because one of the things that I've taught Python to a lot of Java programmers over the years. And one of the things, and when we talk about design patterns, I noticed that many students believe that design patterns are universal, because if they look at the original book, they will see examples in C++, but almost everybody these days have almost everybody who has learned design patterns at the university have learned it with Java examples. So then people make an assumption, okay, so these patterns, the original book talks about these patterns in C++, and we are doing examples here in Java, so they are universal. And a few of them are universal, like the facade is one example of a design pattern that makes sense in any object-oriented language, but not all of them. Yeah, certainly feels like Java to me. So let's look at an implementation that looks more like Python. So this is the idea of using a first-class function, right? So in this example, you see that the API has changed a little bit, because instead of passing an instance of a promotion, we are just passing a reference to a function. Right? And here's a diff that shows on the left side the classic strategy, and on the right side the Pythonic strategy, let's call it that. So what you see is in the do method, the first pink line on the left, you see that you invoke the discount method on the promotion object, and in the right hand side, the first green line on the right hand side, you just invoke the promotion, right? Because the object that you got as a promotion is not an object that has a method called discount, but it's actually a function. And the implementation becomes much simpler. You don't need to have the abstract class, and you don't need the classes at all. Just the logic is in standalone functions. So you see the fidelity promo is just a function on the right side here. The book item promo, again, just a function. So a lot of code you just throw away, And actually, this is also more efficient because you're not instantiating each promotion a million times. You're just passing a reference, and the promotions are functions, and functions are singletons in Python, right? You just have one implementation of large order promo, and that one implementation is shared with all the orders that are being processed. So you don't need the flyweight pattern to make this lightweight, because it is already lightweight. So this is an example that's in my book. I would like to know if it's clear, the transformation that we did, if it's pretty obvious to everybody or not. I don't know. But anyway, it's for people who have worked a lot with Java. It's something that when they look, oh yeah, we can do it like this. Interesting, right?
So if I follow, what this kind of means is that the limitations in a language dictate the need for certain patterns where they're obvious or unnecessary in more flexible languages.
Exactly. That's exactly the idea. So that's why I actually wrote a little comment here that I didn't call attention to it. But for instance, here, the first slide of the design pattern section, I say when languages fall short. Paul Graham, who is a famous blogger and also the owner of Y Combinator, he has an article that's really good. I think it's called The Revenge of the Nerds. I don't remember. He has several articles that are really interesting. But in one of the articles, he says that design patterns are always about language limitations. And that in Lisp, he never feels the need of doing a design pattern, because if he sees a pattern that is repeating in code, in Lisp code, then he knows that he needs to do a macro that will, abstract away that pattern. So in doing a macro in Lisp basically means implementing new keywords. This is the power of macros in Lisp and Elixir and Clojure and languages that have this idea of syntactic macros, means that you can actually extend the language not only by creating new functions, but actually creating new keywords that change the rules of computation. This is really powerful. But yeah, I totally agree with that interpretation. It's this strategy pattern becomes much simpler. Now there's a situation where you can think that the original version has an advantage, which is, let's suppose you want to parameterize the promotion, because the promotion has a certain business rule about how it's applied. This business rule can take into account either attributes of the customer or attributes of the shopping cart. But maybe you want to parameterize the percentage amount. And in the first case, since you are instantiating, right, you could, let's see, in this example here, for instance here, I could pass an argument to the constructor of book item promo to say what's the percentage that I want to give, the percentage discount, right? Okay, but there's also ways of doing that so we've already seen this example. Now let's talk about parameterized strategy. So the idea is this idea of creating each promotion instance assigned to an order will have a different value will potentially have a different value for the percentage. So, but you can do that with a closure in Python, right? You don't need a class. You could do that in a class, of course, but you can also do it with a closure. And how does that work? Like this. So now what we have is the promotion function now receives a percent argument, and the body of the promotion function defines this inner function that I call discounter, and the inner function takes the order as arguments. But it has access, it can read the value of the percent value that was passed to the author function because of the closure mechanism, right? So what happens is basically this invocation here of, for instance, book item promo with the argument 10 on the third line of this example, this invocation produces a closure with that inner function. And with that inner function bound to the percent value of 10, right? So this is one way of doing it. So to contrast with the previous way, each function now becomes a function that has an inner function that is the discounter, or it may be an anonymous function. Like in the first example, I used lambda, but the lambda in Python is very limited. So only the first example looks good with lambda. The others would be very difficult to do with lambda. Anyway,
Luciano,
yes.
sorry to interrupt you, but I just realized, and I think it's funny and interesting that this parameterized function pattern that you're using in Python, it's only necessary as a pattern because you don't have native, how do you call them, curried functions in Python.
Yes, curry. Yes,
So,
totally. Yeah, very good.
But
this is a great insight. I'm actually going to use this the next time I talk about it. Yeah, exactly. If you could curry the function with the parameter,
you wouldn't
then
need that pattern at all. So it kind of proves your point.
Exactly. Very good, Fernando. Very good. But there's another way of doing this in Python, which is very Pythonic, which is sort of a hybrid between the functional approach of using first-class functions and the object-oriented approach, which is again having a class, but this class, the promotions now, they implement the undercall method. And undercall makes the instances of a class callables. So they behave like functions, right? So this is one way of doing it that is probably looks more familiar to people with an object-oriented backgrounds. And it's not so much different from this one. You still have this inner function, but now we have, instead of an inner function, is the undercall method inside each class. But it's one way of doing this in Python. And the interesting thing is that this implementation with the with the undercall, with the callable class, the API would look like the one from with the closure, right? Because when you invoke the constructor here for the book item promo, for instance, on the third line, what you get is an object that you can invoke as a function because it's an instance of book item promo that defines the undercall, right? So this is the implementation in this other way. And now to wrap up, which is more idiomatic. So like Fernando observed before, the classic strategy fills two verbose in Python. And I put a star there, an asterisk to say, yes, this is subjective, but we are talking about style here. One thing that I like to say, to point out, is that when you learn a new programming language, some of the things that you learn with a new programming language are not strictly technical. Each language has its own aesthetics as well, right? And it has its own culture, cultural values. All of this exists. But when people discuss preferences in programming languages, people try to make the case using just technical arguments. But really, the reason why I think that the reason why people love or hate languages is related to technical reasons, yes, but also strongly related to cultural and aesthetic reasons that are harder to talk about, but that certainly exist. Anyway, so the second way, using first-class functions, is very common in the standard library of Python. Like, for instance, the sorted built-in function has a key argument which receives functions, which receives a function. So first-class functions are very common in the standard library. So you can say that it's geometric Python. And about the parameterized version, the use of closures is common in Python, not as common as it is in JavaScript, for instance. Everybody in JavaScript uses closures a lot. Python did have a limitation in Python 2 about how to declare mutable variables in a closure, but this non-local keyword was introduced in Python 3 so that we can use closures better. But the other approach, the fourth approach that I showed, the second approach with parameters, the one using callable objects, is pretty Pythonic. You know, before Python, I had never seen a language that had this characteristic of being able to create instances that behave like functions. It's become more common afterwards. And interestingly, when I did research for my book about decorators, Graham Dumpleton is a guy who has written a lot about decorators, and he also has a library for doing decorators. And he actually recommends callable classes as the best way of implementing decorators in Python, and not using closures, because he says that decorators, to actually work well in different contexts, need to be more complicated than the didactic examples that we see of decorators around the web. And when they become more complicated, they become more readable when implemented as classes. That's his opinion. Okay, so to wrap up, the idea is that you should learn the fundamental language features instead of focusing on paradigms, because paradigms have this problem of, some languages fit very well in a certain paradigm, some don't fit so well, some are called hybrid languages. So then you can, if you're just thinking about paradigms, they don't guide you as well as when you think about fundamental features. So given that, A, B, C, D, E are languages, it's more interesting if you think about, okay, so A, D, C, and E have, I don't know, first-class functions. The orange star means first-class function. So these languages that have this feature, that means regardless of whether they're called functional languages or not, the fact that they have first-class functions means that some patterns or some solutions make sense, while others, while in the F, G, and B language that don't have this feature, some solutions wouldn't make sense. So that's the idea, to focus on the features. But if you look at this, maybe you think that this is actually easier to understand than this. But you can actually reorganize this information in this way, which was what I tried to do in this other slide, right? So think about the features and the different languages that you know about, and start doing these checkboxes, and then you're going to have inspiration about, oh, this pattern that I saw in this other language also makes sense in this language, because those languages share this characteristic, which is essential for this pattern. Or this pattern implements a feature that is missing in this language, and is also missing in that other language, so I can take advantage of that. Anyway, so that's the main idea of this talk, to understand that programming paradigms are very broad and languages don't always fit very well. But if you go one level deeper and think about the features, then things start making more sense. So it's a good investment to learn about these programming language fundamentals, because this will allow you to learn new languages faster. It will allow you to leverage language features that maybe you didn't pay attention before. It will allow you to choose among alternative implementations, which implementation makes more sense in a given language. Like in the first example, when we talked about the recursive version of the the Gcd algorithm, right? It allows you to make good use of design patterns, because the design patterns are pretty much tied to features that exist or features that don't exist in the languages, and allows you to emulate missing features when they're missing. So yeah, I know I learned this feature in this other language, and now I'm working with this new language that doesn't have that feature. So how do I do that in this new language, right? So for instance, Go doesn't have iterators. How do you implement iterable collections in Go? When I started studying Go, that was something that bothered me, but then I discovered that in the standard library, they have a certain pattern that they use when they want to do something that's iterable. Anyway, so that was my message for you guys. Gracias por invitarme.
Luciano,
And yes.
and excellent advice. I couldn't agree more with what you just said. The why learn the fundamentals. That is something that I insist a lot in my own classes, and it's a whether I'm teaching Python or Objective C or Swift. It's when in Rome, do as the Romans do. Learn why the locals do things in a certain way. There's probably a very good reason for that. Usually,
Yes, totally.
Otherwise, you just end up reinventing the wheel, and usually the flat tire, not the wheel.
Yeah.
So
Yes.
if you
Exactly.
understand the core of the language and the frameworks, and I think in your book you explained very well, go learn the Python data model. That's kind of the Tao of Python.
Yes.
In the Cocoa ecosystem, it would be either the NS object interface, or in Swift, the basic interfaces of the language. You learn that you get superpowers. You can offload
Yes.
maybe 50% of your work to the language or the framework, so you have extra time for playing games at work or watching YouTube videos like this one. So it's an excellent
Exactly.
advice, the one that you're giving here.
Yes, totally. Yeah. So do people have other comments or questions?
There are some people asking for a free copy of your book. I'm not sure that's a question. Nice try.
Yes, nice try. Well, I can't give free copies of my book, but I'm sure if you search on the web, you're gonna find them. Not free.
Absolutely. Yeah. Just go
Yeah,
to
free.
Amazon. It's well worth it.
Don't tell. No, no. But I'm also saying that sometimes I recognize that people sometimes can't afford to buy a book, but there are PDFs of my book floating around. I won't give it to you because I could get in trouble with the publisher. But if you can't pay, it's better, because then the quicker I get back the amount that I invested in the book, because I stopped working for part time for 9 months and full time for 9 months. So there's if you maybe 4.5 plus 9, so it was 13 and a half months of full time investment that I put in the book. And if I can recover that, as the faster that I can recover that, the easier it will be for me to write another book. So, and I would love to write another book because I like the experience and the readers like the book. So I think it's, but if you cannot afford, just, look it up and you're going to find PDFs floating around.
I'm pretty sure they know how to find it, and get the book. It's really worth it, and I'm really looking forward for another book from you. By the way, this Sunday, not this one, the next week, I have to teach a class on fundamental architecture of mobile applications. And if you don't mind, or even if you mind, I'm going to steal some of your ideas. I'll give you credit, but I'm going to steal them.
Don't worry, please do. And yeah, actually, maybe I need to find some time to go learn mobile programming with you, because in my career, I have a long career, and before the web came around, I was very much almost every program that I developed as professionally before the web were highly graphic, and I really loved programming the front end. The user interface, animations, choosing the right idioms for the interface. I read a lot about user interface design. It's really an area that I loved. But then when the web came, my first job on the web was actually a programming manager, was a technical manager. So I didn't program. And after that job, when I went back to programming, because I really like programming, I tried very much several times to like front-end development on the web, and I hated it every time. But I think maybe with mobile, it looks more like the kind of GUI programming that I did, in the 90s in some ways. And I would really like to. Actually, I'm really interested in Flutter. Have you heard of Flutter?
Yes, yeah, Flutter, yeah, it's quite interesting. I'm also looking into it right now.
Yes.
So
Yeah.
looks like we're in sync. Yeah.
Yeah.
Excellent. So we have a lot of stuff to talk about. Next time I go to São Paulo, we need to have a beer or two, and we can talk about programming and also some fofocas from Bireme and Isis.
Yes, and it was nice meeting you and Nacho. I look forward to going visiting you in Madrid sometime. And so yeah, let's make it happen.
Absolutely. If you ever come here, let us know. It will be a pleasure. This was a pleasure having you here. Thank you very much.
Thank you very much. Bye-bye.
Bye-bye. Thank you.
Bye.